today we're going to continue with section 2.4, solving equations with variables on each side. Now, the next vocabulary word here is called identities. Here it says some equations may have no solution. That is, there is no value of the variable that will result in a true equation. And sometimes, some equations are true for all values of the variables. If we have this case, equations that are true for all variables, then that means that we have identities. In other words, here, if it says, like it's, for example, 0 equals 0, once you finish simplifying, and you get a 0 equals 0, or an 8 equals 8, or an x equals x, or a 2 equals 2, they're exactly the same. That means that this equation is true for every value that you put in for the variable. Okay? If you solve an equation and you end up with a false statement, 5 is not equal, or if it says 5 is equal to negative 12, that's not true, right? 5 is equal to negative 12. If that's if you end up with a false statement, then that means that that equation has no solution. Is everybody clear with that? So if we have a true statement, like in the second example, okay, that means that you have all real number solutions. Anything that you put in there will be true. Or if you have a false statement, like 3 equals 5, then this means there are no solutions. Okay? So with the examples here, all we're going to do is we're going to simplify as much as we can. If it's an equal true statement at the end, then the answer is it is an identity, which means that we have all real number solutions. Anything will work if we put it in there. If we simplify to the end and we end up with a false statement, then the final answer, no solution. Okay? So let's start simplifying. All right. So the first thing we want to do is we want to get rid of the parentheses. And how will I get rid of the parentheses? Very good. We're going to use the distributive property. So we end up with 7x plus 5x minus 5 is equal to negative 5 plus 12x. Right? Now we can combine like terms. When we combine our like terms, on one side over here, we can go ahead and put those together. Now, those are on the same side of the equal sign. Let me ask you this. Do I use inverse operations or do I just add them? Very good. You just add them. If you're on the same side of the equal sign, you just add. No inverse operations. So that's going to be 12x minus 5 is equal to negative 5 plus 12x. And now, we're going to simplify it to the end. Okay, so we're going to get rid of our variables. So we can combine the 12x and the 12x, right? By doing what? Subtracting 12x on both sides. So when we do that, 12x cancels here, 12x cancels there, and we end up with negative 5 is equal to negative 5. True statement means that what is it? Starts with an I. Identity. It is an identity. And what does it mean being an identity? You can, very good. You can plug in any number and you'll get a true statement, which means that the answer is an identity and the solution is all real number solutions. Okay? So, therefore, all real number solutions. All right, and example 4 is writing an equation. Okay, there are many situations in which you must simplify expressions with grouping symbols in order to solve an equation. So here, the example that they give us is that we want to find the value of x so that the figures have the same area. How do I find the area? What's the formula for the area of a rectangle? Base times height? Length times width. When you're dealing with two-dimensionals, it's length times width. Okay? So here we're going to have length times width, the x times a 10. There's a 10x. And we're going to set that equal to, because we want it to be equal to the area of the other rectangle. So that's going to be 3 plus x times 6. Is everybody with me? Now, when we set them equal together and equal to each other, and then we solve them here, once we write our equation, then we have to test to see which answer is going to be the correct answer. Okay? So, here, the first one they're going to put in, they're going to substitute in, they will substitute 3 in the first equation, right? Okay? So when we simplify that, they end up with 30 is equal to 36. That's a false statement, so that's not a solution, right?
Should we be writing all this down?
That's not a solution. Here, then we're going to substitute in 4.5. Once we substitute 4.5 in, right, then we get a true statement. 45 is equal to 45. Since that's a true statement, that 4.5 is a solution. Does that make sense? So if you are substituting into an equation and you get a true statement, that means that that number you substituted into the equation is a solution. Here, when we substituted in the 3, we got a false statement, right? That means 3 is not a solution. Does that make sense? All right. So, and since here they found the solution, then you don't need to check C and D, right? That's test strategy. All right. So let's do some examples. For the next example, it says find the value of x so that the figures have the same perimeter this time. You guys remember the formula perimeter? What's the formula for the perimeter? That's one you need to know. So there's our perimeter formula. Now, we want to make it so that both of our perimeters are equal. All right, so now we simplify a little bit. So here we're going to have 12 plus 2x is equal to 6x plus 4. And here, at this point, is where we will substitute in our values for x. Is everybody with me? All right. So,